Good morning, dear students. Welcome to another session of Introduction to Data Structures and Algorithms. So, in previous session, we started off our discussion with respect to arrays. So, in this, we discussed what is an array, what kind of data you can store in that, and what are the characteristics pertaining to the arrays. So, and what is one of the major drawbacks which are concerned with the arrays. So, these are a few of the discussions what we had. And then apart from that, we discussed what are the different types of arrays. In that, we have one-dimensional array and multi-dimensional arrays. Then we looked into how arrays, one-dimensional array is represented in memory. So here, if I again make a recap of this, what we will be having a name associated with the array, and then there will be an index associated with the array. Since it is one-dimensional, I'll be having only one index. So if there are n number of elements present in the array, say if I consider that the size of the array is n, so then I can have n number of elements, and all these elements will be stored in consecutive memory locations. And if I want to access these elements, right, I can make use of the name of the array along with its index parameter. And if I know the base address, and if I know how much is the word size pertaining to an array element, say if it is integer, it might be 2 bytes or 4 bytes. So dependingly, you can estimate what is the address location of some of the element, say having index 4, having index n minus 1. So any this thing we can estimate using these parameters. So this is what we had discussed. So next topic what we discussed was how do we look ahead for array traversal. So basically what is traversal? We try to read through the elements of the array by visiting each of the array elements, and in the process we might be sorting it or retrieving it. So this array traversal is basically looked into when, say, you are either sorting the elements or retrieving the elements from the array. So one of the examples what we can look is, if I want to print what are present in the array, then I look for traversal of the array elements. So if I have to print the elements, then I traverse the array. This is one of the cases where we are looking for traversal. Then if I want to search for any element, then I again go for traversal of the array. If I want to sort the elements, then I look for traversal of the array. So if any other features has to be looked in, say if I want to delete an element, again I have to traverse through the array. So in previous this thing we had observed the same condition. So in which we were looking out how we actually traverse through the array elements and how do we print it. So because why we need to discuss this is because henceforth we will be looking forward for utilizing this logic when we are either sorting, searching, or just we want to print the elements. So if you are doing any of these things, you have to traverse through the array elements. So we had discussed regarding this program. So here you can observe what is the logic. So we are interested in this part. So here basically if I observe the other things, right, it is of, if I make an observation of the other things, it is your basic elements wherein you are declaring an array which is consisting of 5 elements and the name of the array is ARR. So this just for temporary purpose I had written it, so no need to worry about this at present. Even this is an array which is an array of characters which you call it as string, and then we are declaring an integer variable n which is equal to 5. So this is basically telling me how many elements are present in this. So this is hard coded value. Generally when you're doing programming, right, you don't go for hard coding. You prefer for doing a soft coding wherein you try to set this one in a dynamic form. You give the liberty to the user. So that is what you try. Since we are just trying to observe what is the logic we are going to implement, so we have considered the hard coded value over here. So if I try to count the number of elements here, I have the number of elements in the array is 5. So here what we are doing, we are just printing what is the address. So we had observed this in the previous case. So again, we'll be looking into that. And remember, getch is used to hold the screen. So if I don't use that, what happens? You can just check out in one of the programs. So then here we are calling the function which is named as traverse. And then we are moving ahead with the rest of the part. So when we call the traverse function, the program control moves to this part wherein the function is declared. So again, here we can see that this is the prototype. So what is this telling? This is telling what the function is accepting and what it is returning, and what is its name. So here void implies that the traverse function is not returning anything. The name of the function is traverse, and what are the parameters it is accepting? It is accepting the parameters int star, which identifies that this is a pointer. This is a pointer. Since star is there, this is a pointer, and this one is just an integer variable. So when int star is there, when you're passing the parameter, you should make it clear that when you're passing these things, you should pass the address, since int star is there over. So that therefore, based on that, what you have ARR. So ARR in array, when you're dealing, right, whether it is integer array or character array, float array. So one special thing of arrays is if you're passing just the name, it is equivalent to passing the address. It is equivalent to passing the address. So that is one special feature. But if I want to pass this value and I want to pass the address of this, so this is just an integer variable over here. It is not an array. So in such cases, what we do is we pass the address of this one with the help of ampersand. I write. So suppose in this case, I wanted to pass this address of this one. Then what I would write? I would write ampersand n. So which will tell what? It will pass the address of this variable. So at present, we are passing the address of this array, and n is the value what we are passing. So here we are not passing the address, we are just passing the value. And here what we are doing, we are passing the address. So whenever we consider passing the parameters, we have two things, one by pass by address and one by pass by value. So those two parameters, that is this array ARR, which is there, it will be stored in array which is represented over here. So this parameter which is there, it is a pointer. It is a pointer which is pointing to the address of this elements, and size will store the value of n. It will store the value of n. So now here just another point to note down is, since you are passing ARR by address, what happens is whatever changes, if you incorporate over here in this function, if you do some changes to the array elements here, it will be reflected back in the main function, that is the function which is calling it. But if you do some changes to size, so if you write size is equal to size minus 1, so the value turns out to 5 minus 1, which is 4. So here what happens is, in the main function where you're calling, this value won't be changed. This value won't be changed. Suppose in array, right, if you add or delete any of the elements from the array, so that also will be reflected over here. So that is pass by address. If you just pass by value, it will be like local to this one. If you pass by reference, you're passing the address. So any changes incorporated using that address will be reflected back in the function which is calling it. So here the logic what we are looking is over here. So here what we have a declared integer I, and then in the for loop we are traversing through the elements of the array, and then we are printing it. So as per the logic of for loop, what we have an initialization condition wherein we initialize the index, then we check for what is the condition based on which the loop has to be executed, and another parameter is the increment or decrement operation which is performed on the index. So now for the first time when you encounter the for loop, this statement will be executed, which is I is equal to 0, and this statement will be executed only once. So once this is done, it the program control goes to next point, that is the next statement. It checks whether the condition is true or not. If this condition is true, then only the for loop will be executed, else for loop will not be executed. So here what we have, I is equal to 0, 0 is less than size, size is how much, it is equal to 5, that value you have passed through n, so size is 5, 0 is less than 5, so the condition is true. So therefore what happens, this statement gets executed. And here you can observe that you don't have parenthesis. So if you don't have parenthesis, here you can make an observation that for this for loop, only one statement forms the block for the for loop. So only print statement is relevant to the for loop. So this is anyways a comment. So here what we are doing, we are printing the elements. So printf array, you are specifying arr %d. So which index element you are printing and what is the value of that element. So I is the index. So in the first pass it will be 0, and this one will be the value 2. This one will be the value 2, array of 0. So similarly, what happens? So once this is executed, it goes and increments I. So I will be 1 in this case. So once this is done, it goes and checks the condition again. So when I has incremented, I became 1. 1 is still less than 5. So therefore, print statement goes and executes. So here in the next iteration, what it will be, array of 1 will be equal to 6, will be equal to 6. So this continues till this condition is satisfied. Once the condition fails, it comes out of the loop and the control returns to the function which has called the traverse function. So if I observe, so we'll just have a look at the same program here. So here we can observe so here you can observe that what is the elements which are present in ARR. So here you can see that initially it is garbage since it is not yet initialized. So it is declared, initialization has to be processed. So once you complete the execution of this statement, the values change over here. So ARR is having these values. So at present, char str, I'm not interested. So value of n is 5. So what you're doing, you're printing the address of 0 and address of 1. So let us see what will be printed. So now if I don't have this get ch, I'll not be able to see what is being printed over here. So if get ch is not there, I'll not be able to observe this, or else it will just print and just come back. We'll not be able to observe it. So now get ch will be executed. So we came to the screen. So here we can observe that when we are using the editor of Turbo C, what is happening? The address of ARR of 0 is 65516, and whereas the next element address is 65518. 65518. So based on this, what we can make out, so in this case, the integer is consuming around 2 bytes of memory location. It is consuming 2 bytes of memory location. So the next statement, array of string, address of string array. So there I was just trying to see how much bytes of location, how much bytes of memory has been consumed by the character. So you can see that The first character is at the address 65512 and the next character is at 65513. So what does this indicate? One character consumes around 1 byte of memory location. So now the cursor is blinking over here. So this would not be observed if get ch was not present. So you press any of the key, it will return to the program. So now what we are doing, we are calling the traverse function. So now what has happened? So when we do the call for the traverse function, the control moves to the traverse function. So now int I is executed. So now here you can see that I is having some garbage value. That's why you need to initialize it. Either you initialize here or here, but be careful when you're utilizing it in these conditions. So now when I execute the statement, this has to be executed for around say, since 5 elements are there, it has to be executed for 5 conditions, and for fifth this thing it should come out of the loop. So I is 0, the condition is satisfied. What is the value of size? Value of size is 5. We can observe that value of size is 5, index is 0. So now what will happen? Array of %d, that is here it is I, and this one is array of 0, that whatever index is there. So therefore what happens is this will print, it will print the element, it will print the element. Now here we are not able to observe this one because this is the address parameter. It is storing the address information. It is storing the address information. Now this one is not being displayed because this is local to main function. This is local to main function. So now we'll not bother about those things. So now you can observe the value of I as and when I keep on executing. So I'll go to the next step. So I became 1. So again, the statement is true. That is I is less than size. So then again, I became 2, 3, 4. So for 0 to 4, this statement will be executed. Now when I becomes 5, 5 is less than 5 will be false. That is I less than size. 5 is less than 5 will be false. So now you can observe I became 5. So when I incremented and became 5, when it come out of it comes out of the loop because the condition fails. Because the condition fails. So now again we are using getch to observe what is printed on the screen. So here we can see that we are able to observe ARR of 0 is equal to 2, ARR of 1 is equal to 6, and so on. So again, I come back to this one. So getch, it will just show the screen. So now I come out of the loop. So here we can observe that how we are traversing through the array elements. How we traversed through the array elements. So this is pertaining to array traversal. So now next what we have is the insertion and deletion operation. So as we can see that an array is nothing but it consumes a contiguous memory locations. Now since suppose we have declared an array of size 10, but we have stored say only around 5 elements. So remaining 5 locations are free for me. So in these locations, so it implies that total 5 elements can be inserted into the array. So that is one thing. Now where the insertion can happen. So what is basically insertion? You are adding an element to the existing array elements. To the existing array elements. Now in when we are talking about insertion, right, we have two things. One, I can add the element at the end of the array, and another thing is I can add the element anywhere in the middle of the array. Now let us observe what happens in both the conditions. So now let us assume that this is the initial status of the array in which I am having around say 5 elements. So from A of 0 to A of 4, where A is the name of the array, and within the square brackets we are having the index pertaining to the element. Now in this case, the first thing, we want to insert element 4 at the end of the array. So in this case, what happens is, first we need to traverse through the array. First we need to traverse through the array and see where is the last element. This is the logical aspect what we are talking of. This is a logical aspect. So we get to know that the end of the array is A of 5. A of 5. So we directly insert the element 4 at A of 5. That is, index is 5. So here you can observe that we are not disturbing any of these elements. We are not disturbing any of these elements, and we are not disturbing the indexes which are associated with these elements. So if I'm inserting an element, say 4 in this case, at the end of the array, then in this case, the indexes of the previous elements are not disturbed in the array. But what about inserting an array element in the middle? So here you can see we want to insert an element 4 at the index location 2. We have to insert element 4 at the index location 2. So this one is keeping the initial array in mind. So this is the initial status. So at this position, I want to insert the element 4. So that is the index 2. So if I'm doing this, then what has to be done is, so here you can see that this element 5 should not be disturbed. I cannot delete this element and directly insert the element 4 over here. So what we are doing, we shift each of this one bit or one location towards right. So here you can observe 5 is shifted to the next location which is having index 3. 22 is shifted to the next location which is having index 4, and 77 is shifted to the next location which is having index 5. So when you shift this, what happens is this location becomes free. This location becomes free. So in that position, what you're doing, you are storing the element. You are storing the element. That is the element 4 in this case. So here, basically, what you do is you are considering one element insertion at a time. So if you have to insert in between, what is the logical aspect? You start off from the last element. You start off from the last element. This one you shift to the next memory location or the next index. So if the index is 4, you have to shift it to index location 5. Similarly, 22 has to be shifted to index location 4. Then 5 has to be shifted to index location 3. And this one will be free. There you insert the element. So here, when you're inserting the elements in between, what is happening? You can observe that the index elements are altered. So in this case for 4, these elements index are altered. These element index are altered and new element is inserted in between. Now next one is observing the deletion operation. So in deletion operation, what we have to say remove one of the element from the array. So in this process, we can observe two cases. That is, one, what happens when I want to delete the element which is present at the end of the array, and what happens when I want to delete the element which is present in the middle of the array. So again, let us assume that the initial array elements is arranged in this form. wherein I am having 5 elements. Now, in this case, I want to delete an element which is present at the end of this array. So in the initial array, you can observe that 77 is the last element which is present in the array. This I want to delete. So in this case, I just go and traverse the last element and delete it. So if you just observe, these are again undisturbed. The indexes are not disturbed for these elements. So this will be the array after the deletion operation. Now what I want to do is I want to say delete the element from middle of the array. So element at index location 2 has to be deleted. So in this case, again, what we do is we consider the initial array. With respect to this, we observe what is happening over here. So what is the element which is present at location index location 2? It is 5. So this element has to be deleted. Now when we are performing this operation, right, you can see that here we have array of 1, array of 0, array of 1, array of 3, and array of 4. Now by definition, what we have, array elements say are stored in consecutive memory locations. They're stored in consecutive memory locations, because of which what happens is these indexes are also associated in consecutive way. So if 0 is this, 0 is there, next element will be identified with the index 1, next element with index 2, next element with index 3, and so on. So I need to maintain this. So when we delete this element, delete this element, what happens is this memory location is free now. That is, it is not having any element. So in this process, what we have to do is we have to store this 22 in a index location associated before it, because after 5 we have 22 and 77. So what we have to do is we have to shift this to its previous index location and 77 to the position of 22. So that is what is being done over here. So logically speaking, what you have to do is first you need to identify in the initial array which element you are deleting, which element you are deleting. So at that location, what you do is you consider the next element in the array and store it in the next position. You consider the next element in the array and store it in next position till all the elements are inserted. So till the element is deleted and arranged in proper form. So here you can see that the after deletion, the array is maintaining its definition. That is, the elements are stored in consecutive memory locations. So each of the elements can be accessed with its respective indexes, which are the consecutive numbers. So next we'll look at a program in which we'll be looking ahead with array insertion and array deletion. So before going into the execution of the program, we'll just discuss the program here itself, and then we can go to the execution part. So here you include the header file, you give the name of the function. So in this case, it is the main function. Then we are declaring an array whose name is itself array, and it can store around 10 elements. And in this you have stored how many? 1, 2, 3, 4, 5 elements. So 5 elements are stored in this array. And you're declaring a few of the other parameters which are required in the program. So let us look at these when we go through the program. So n is equal to 5. This is nothing but this is hard coded, telling that there are 5 elements in this array. Here we are having 5 elements. That is the indication what is given by this. So in this one, what you're doing, you are traversing through the array elements. The previous logic, previous program, what we discussed. So in this one, we are traversing and printing the array elements. We are printing the array elements. So this part, we can observe that it is over here. The contents of the array are all printed over here. So now next, what they are doing. So this is array traversal. This part is looking into array traversal. So next what they are doing is they are asking the user to enter the element that has to be inserted. You have to enter the element. So in this one, you can see that in scanf, you are using ampersand P. So P is storing what? P is storing the element to be inserted into the array. P is storing the element which has to be inserted. Then you are using printf, enter the index location. Enter the index location where this element P has to be inserted. So this percent you can observe that it will be replaced with the value which is present in P. So the index location you are storing in what? You are storing in K. So index location is stored in K and the element value is stored in P. So these are the two things which are happening here. Now next, what is the logic I have to follow in order to insert this element P? So whatever value is present in this P at this index location. So what is the logic? So here you can observe what we are having for I is equal to N. So what is N? N is 5. So 5 indicates what? There are actually 5 elements which are present in the array. So you start off with what? You are starting off with the last element. You're starting off with the last element. So let us look at the logic over here. So here this one is printed here itself. You can observe that you have array of 0, 1, 2, 3, 4. What is the next memory location you will be having? You will be having the next memory location at array of 5. You'll be having at array of 5. So here what we are doing is, if you just observe, I is equal to N. So which is telling that I is equal to phi in this case. Phi in this case. Then what you're doing is you are checking this one to identify whether you are inserting the element at the end or you are inserting the element at the in between. You are whether you're inserting at the end or in between. So you have initialized I is equal to 5. Now in this condition, right, 19 is the element what you are inserting and you are inserting it at the index location 1. So here that element should be appearing and these all should be changing. These all should be changing. So we'll discuss with respect to this logic. So at index location 1, I want to store. So here what we are having k is equal to 1 and the p value which is there, it is equal to 19. P value is 19. So I is equal to 5. 5 is greater equal to k. So what is the value of k? K is 1. So 5 is greater equal to 1. So condition is true. Condition is true. So what is this telling? That if it was equal, if it was like 5 greater equal to, if I had specified that index location was say some 6, so the condition would fail over there and it would give an indication that you are inserting at the end of the array. So at present we'll not get confused with this parameter. So now the condition is true over here. Therefore, what happens is array of I plus 1. So basically what you're doing, array of I plus 1 is stored with array of I. So here what is happening, since you are inserting the element, so we'll consider this case. So since it is in between, so in this case, what we had done, we had inserted element 4 at location 2. So what we had to do, we had to shift all these elements towards the end. So here we can see that there are totally 5 elements. There are totally 5 elements. So if I have to access the next this thing, it is nothing but a of phi. So this phi is nothing but the number of elements which is obtained from n. So what we do is we first shift this element to this location. Next, this element to this location, and this element to this location, and then we insert the element. So here basically we are doing the same thing. So array of I plus 1, array of I plus 1 is equal to array of I. So that is what is happening in this case. Then so here what you do is this will be executed till you reach till you reach 1, till you reach 1. So in this one what is happening? So at array of 5, this element will be stored. At array of 4, this element will be stored. This is for the first iteration. This is for the second iteration. I am talking from this for loop point of view. So next one, array of 2 will be stored in next location. Array of 1 will be stored in next location. So what you have done is you have freed up array of 1 space to insert the element. So because the condition you can observe, I is greater equal to k. So k is 1 in our case. K is 1 in our case. So once this is decrement, I minus minus. So once I reaches 1 and it decrements, so the condition fails. The condition fails. So all these operations are being performed. All the elements are moved one location down. One location down. So now what we have is array of k, that is array of 1 is free. So there we directly store the elements. Now since we are adding one element to this, the number of elements will be incremented by 1. So previously there were 5 elements, now there will be 6 elements. Now there will be 6 elements. So what is you can observe what is happening over here. So again, what you're doing is you are traversing the elements and you are printing the contents which are present in the array. So this part is important for us. This part is important. Logically speaking, this is correct. Logically, it is correct. Only one change what I would suggest is if you know that there are 5 elements, the index of the last element will be n minus 1. So here instead of starting with I is equal to n, you can start off with I equal to n minus 1. You can start with I equal to n minus 1. So even that is also correct. Logically speaking, this would be better. But even if you're using I is equal to n also, that will not create any problem. But see that it doesn't overflow. So we are assuming that we are not doing any underflow or overflow operations over here. So we are assuming those things and we are performing the operations. Okay. Okay. So let us see the execution pertaining to this program, what we have discussed. So while I is already there, array is already there, I'll just add the watch for k so that it becomes easy for us to observe. N is 5. P is the element what you want to insert. Okay. Any other parameter? Okay, no other parameter. If you want, you can just store n also. Since only one value is there, I was just avoiding it. So now we'll try to execute this program. So we have executed. So arrays, array, this thing is not there. It went out. I'll add watch to the array itself. So what we have, so we can observe that here we have 10 locations. So this array will be provided with 10 memory locations. And in this case, what we have done, we have just initialized the first 5 locations. So this array is having only these 5 elements, only these 5 elements. Okay. So now we continue with the execution. So n is so we have declared all the elements. Now n is equal to 5, indicating that there are 5 elements presently in the array. So n changes to 5. So previously it was all garbage values. So now you print the contents of the array. So this is array traversal. So now since we are not using the getch function, what happens is I'll not be able to go to the screen. So here, so you can observe that after printing, it has not gone to the screen console screen. So now here you can observe that what it is doing is it is asking to enter the element that has to be inserted. So since scanf function is being called, now we go to the screen. So here you can enter the element. So there the element was 19. So let us observe whether 19 will be inserted in the index location, which we can look out for. So here the index location is considered, say 1. Okay. Sorry, I need to re-execute it because the numpad was locked. Okay. So element which has to be inserted is 19. And the index location was 1. So now you can observe that 1 and 19, p is containing the element, k is containing the index at which you have to insert. Now what is I? Say I'll just keep a track of I parameter over here. So I'll add a watch and see what will be the value of I. So here I is equal to 5. It has been initialized. And whether phi is greater equal to the k value, that is k value is 1. K value is 1. So whether phi is greater equal to 1, the condition is true. Therefore, it goes, just observe these elements. Just observe these elements as I go through the execution. So what is happening? Array of I plus 1, that is in this case it is 5 plus 1, that is array of 6th location will be stored with array of 5. So in this you are referring to the index. So this is 0, 1, 2, 3, 4. This is the element which is present at index location 5. So this element will be first shifted over here. It is for this reason why I had specified that you can refer to n minus 1 over here. That is, you are referring to the index. Even if you refer it to I equal to n, it will not be a problem. So in first iteration, this element will be stored at this location. So let us see what happens. So first iteration is done. Now, once first iteration is done, observe the value of I changes to 4. I changes to 4. Now I is greater equal to 1. K is equal to 1. So 4 is greater equal to 1 in this case. Condition is true. Therefore, what happens? This statement will be executed. Now, what is value of I? I is 4. What is 4 plus 1? 4 plus 1 is the fifth element, the index location 5. So what will be stored over there? Array of 4. So what is array of 4? 0, 1, 2, 3, 4. So this element will be stored in the next location. This element will be stored in this index location, which is given by 4 plus 1, that is I plus 1. So once I execute this, you can see that this element is being stored over here. So 77 is replicated over here. So next, similarly, I need to move 22 to this location, 5 to this location. That time, this location will be free for me to insert new element. So now I will be 3. So I is 3. 3 is still greater than equal to 1. Therefore, array of 3 plus 1, that is array of 4, will be stored with array of 3. So array of 3 is what? This parameter. Array of 3 is this parameter. So 22 will be stored in next location. So you can see that 22 is stored over here. So similarly, I continue the execution. I is equal to 2. So 5 is stored in the next iteration. 3 should be coming over here in the next iteration. So I is equal to 1. So 1 is greater equal to 1. The condition is true. So therefore this part gets executed and 3 gets stored in the immediate next index location. So this has happened. Now I was equal to 0. Once this statement got executed, it went and decremented I. So I became 0. So is 0 greater equal to 1? The condition is false. The condition is false. Therefore, the control came out of the for loop and went to the next statement, which is present over here. Now what is array? So you can see that 3, 5, 22, 77 all are shifted one location towards right in this case. So now what has to be done? You have to store the value directly over here. P is containing the element 19 and K is containing the index. So now what we do is we just execute it. You can observe that -1, 19, 3, 5, 22, 77 are stored in this location. And next you are just printing the elements. So when you print the elements, you can observe that the elements are being inserted. Element 19 is inserted at location 1. So previous elements are all shifted one location below. So this is the example pertaining to insertion in an array, insertion of an element in an array. So now I'll just try to look over. So directly what I'll do is I want to insert element 19 at the index location 5. So whether this is operating, we'll just check out. Yes, this is happening. So program is executing fine in this case. Okay. So it is working fine. Even if I'm inserting at the end, it is working fine. Okay. And even in between, it is working fine. So, but one thing to remember is we are not making any other checks. We are assuming that it is fine. So we are not making any checks over here. Okay. So here we are just assuming that all conditions are fine. Within those premises, we are performing the operation. Okay. So that is what we are looking out for. So this is an example pertaining to insertion of an element in the array. So in next session, what we'll do is we'll have a look into the next part. Okay, wherein we'll look for the deletion of an element from an array.